Okay, Unit 9 was all about quadratic functions. This was our first introduction to the quadratic function family and all of its parts. So here is a beautiful little visual of the parts of a quadratic. We have this orange line that is the axis of symmetry, also sometimes called the line of symmetry. It splits the quadratic in half. And we know that the points on either side of it are going to be equidistant from that line because it is the line of symmetry. The vertex is on that line of symmetry, so those two things are very closely related. The x-intercepts, these 2 points right here, we also called those roots. We also called those zeros. And then we called them solutions in Unit 10 when we talked about solving a quadratic equation. Then there's also always the y-intercept to look for. It's not as important with quadratics, but it is something that sometimes happens if the quadratic crosses the y-axis in the field that you're looking at. Then we have concavity. Concavity is just whether or not it's opening up or down, so this would be concave up. Then we also talked about minimums and maximums. This one has a minimum because the vertex is at the bottom of the graph. Basically, concave up and minimum go together, and concave down and maximum go together. Excuse me. Then last but not least, we talked about the domain and range of a quadratic. The domain, if it's a true function with these arrows or an equation, it's not cut off in any way, then the domain is just going to be all real numbers because it's going to go forever to the left and forever to the right. The range, however, is not going to be all real numbers. The range depends on the vertex and whether or not it's concave up or down. So for this graph, the vertex here is at 1, -4. I think that's right. Yep, 1, -4. So that means the range is going to be y is greater than or equal to -4. Because it's going to go from that -4 point and then all the points above it, all the points up. So here's an example of a star question that kind of touches on the attributes of a quadratic. What is the range of y equals -x² minus 2x plus 3? So I would put this in my calculator and graph it just to see what the function looks like. Most likely you're going to see that it's concave down, which you might remember because if the a value in a quadratic is negative, it is going to be concave down. So then you're just looking, I have no idea if that's what the graph looks like, by the way. Then you're looking at your answer choices. Well, if they're saying range, then we don't want these that have an x. We want the ones that have a y. Then we're going to look to see, do I want y to be less than or y to be greater than? Well, if that negative means it's concave down, then I want y to be less than. So my answer has to be C here. Okay, but again, this would be even easier if you just put it in your calculator and graphed it, and then you could see, oh, this is at 4, so it's just all the points from 4 and below. Okay, so we had two different forms of the equations that we looked at. We had the standard form, which is the one on the top here, and the vertex form. Vertex form is way more helpful in the sense that it shows you the vertex. The h and the k together make the vertex of the quadratic. Okay, and because that is the vertex right here, that means it's also going to give you the line of symmetry. So that h is the line of symmetry as well. Now, the standard form does not have that. None of those things represent the vertex or the line of symmetry. But the a in both of these is the same, okay? It's the same value, but it doesn't really stand for anything. It tells you whether or not it's narrower or wider than the parent function, and it tells you if it's concave up or down, but it doesn't mean like one of the attributes. It's not the x-intercept, it's not the y-intercept, it's just going to represent the transformation from the parent function and then whether or not it's concave up or down. The c value here is the y-intercept, but again, the y-intercept isn't all that helpful with quadratics unless you're graphing it. So, you know, yes, kind of helpful, but also not as helpful as knowing what the vertex and line of symmetry are. So that's standard form and vertex form. So let's talk about graphing a quadratic. What's important is that you first find the line of symmetry. That is step one every time, because that's going to give you the line that all the points can be reflected across. Okay, that's going to help you graph your quadratic more easily. Once you have the line of symmetry, then you want to locate the vertex on that line of symmetry. Okay, then you just want to find more points. So once you have the vertex, then you're going to have to plug in numbers to get more and just reflect them across the line of symmetry. Now, that sounds really easy, except that there's a lot of math involved in this if you're doing it by hand. So remember that the line of symmetry is x equals -b over 2a. And remember, you have to take that from standard form if you're going to use the equation because you need the b and you need the a. The b is only seen in standard form. If you don't have standard form, if you have vertex form, then it's really easy because you're given the vertex and you're given the line of symmetry. If, again, it's standard form, though, and you need to find the vertex, then you would plug in the line of symmetry. You'd plug it into the equation, and you would get a y value so that you could graph it. Finding more points, you just plug in random numbers. Plug in a 0, plug in a 1, plug in numbers that are easy so that you can find some easy points. Now, all that's great, but if we're talking about star, I would just graph it in your calculator. Go to the graph menu, type it in, press graph, and look at it that way. It's going to be much faster and more accurate, and ensures that you're not going to make as many mistakes. Okay, transformations of a quadratic. This was a tough topic for us earlier in the year, but I'm just going to highlight a bunch of transformations in this equation that I've given you, but then remind you that overall, if you can remember these two things, that should help you out immensely. So looking at this equation, the negative at the very beginning means that it has been reflected over the x-axis. It's concave down, okay? This 3, it's on the outside of the parentheses, so that means that something vertical has happened. So this is a vertical stretch by a scale factor of 3, okay? And I remember that it's a stretch because if this is a 3, that means it's narrower, and that means that vertically I've stretched it to make it narrower. This 1/2 is inside the parentheses, so that means that it's something horizontal. This is a horizontal stretch, okay? Because the 1/2 is going to make it wider, and I know that horizontally, I'm going to make something wider by stretching it. Okay, the 4 is also inside the parentheses, so that is also something horizontal, but this time it's being added or subtracted, so I know that's a horizontal shift. Remember also that this +4 means that it's actually going to the left 4. It's the opposite of what you would think. Okay, then going back outside the parentheses, this -8 is a vertical shift down 8. Okay, but again, I would remember these two things. If something is happening inside the parentheses, it is a horizontal something. If something is happening outside the parentheses, it's a vertical something. Try to focus on just those two things. Don't even worry so much about stretches and shifts. Focus on horizontal and vertical. The reason I say that is because let's look at the star questions that have been asked in the past. We've got a graph that has been given to us and says the graph of quadratic function p is shown on the grid. So this is the graph called p. Now, here's the part where it sounds confusing. It says if k of x equals x squared, and p of x equals k of x plus n, what is the value of n? Well, again, we're going to focus on the inside and outside the parentheses. This plus n is outside of the parentheses. And what I mean by that is we don't have anything in here with the x. This n is outside, okay? And it's being added. So they're telling me that we're vertically shifting something. So looking at my graph, if they referred to the parent function, which is through the origin, that means this has been shifted 1, 2, 3, 4, 5, 6 units down. 6 down. So if I'm going to say what n is, it has to be -6. Okay? Now, here's another example. Again, this is why we're going to focus on inside and outside the parentheses. The graph g of x, x equals x squared, which is the parent function, was transformed to create the graph of h of x equals -x/4 squared. Which of the following describes the transformation? Well, this negative is outside the parentheses, so that means that something vertical is happening. That means that we are reflecting it across the x-axis. So I know that g is out and j is out. Then this 4 is inside the parentheses, so that means it has to be a horizontal something. Well, my options are either horizontal or vertical, so it has to be f. I don't even care if it's a stretch or a compression. Stretch is my only option. But really, I just needed to know if it was inside or outside and if it was vertical or horizontal. Okay? So then one of the almost last things we did was convert vertex form back into standard form. And this really relied on your ability to remember things like perfect square trinomials and distribution and combining like terms. So we started by working out this perfect square trinomial. You can either do that the long way over here on the side by doing x plus 4 times x plus 4, or if you remember the shortcut, that works as well. But you would get x squared plus 8x plus 16. But then I'm going to bring down that -3 and the -8 because I haven't dealt with those yet. So now I want to distribute the -3 into everything. So negative 3x squared minus 24x minus 48. Bring down your negative 8. Now I can combine like terms. So g of x is equal to negative 3x squared minus 24x minus 56. So we converted it from vertex form up here down to standard form down there. Okay, and just as a little reminder, remember that this 4 and negative 8, those are the coordinates of the vertex. And this negative 4 is going to be the line of symmetry. Okay, so here's an example of a star question. It's very straightforward. You would just take this, multiply the perfect square trinomial out, distribute the negative 4, and then add that negative 6 with whatever else can be combined. So I know that I'm going to start with negative 4, which they have. When I distribute the negative 4, I'm going to have negative 56x, which narrows it down to f and h. I don't know what 49 times 4 is. 196, negative 196. Minus 6 is going to give me negative 202. You could also just put all of these in your calculator and see which two line up. Okay, the last thing we did was writing an equation given the points and the vertex, okay? And this relied on your knowledge of vertex form. So I'm going to write vertex form without any numbers plugged in, but then I am going to plug in what I know. So looking at this graph, I know the vertex is negative 2, 4. So I'm going to go plug that in where the vertex is. So negative 2 gets plugged in here, and 4 gets plugged in here. Then I also know some points, right? I only need to know one of them, really. So I'm going to use this point, negative 4, 0. And I'm going to plug those in here, negative 4, 0. The only thing I don't know is the a, and that's okay because I'm able to find it now. So I'm going to plug or use all the rest of this. This becomes a plus sign. Now I'm just going to pretty much PEMDAS and solve for a. So I'm going to leave 0 alone, leave a alone. Negative 4 plus 2 is negative 2. Negative 2 squared is 4. So I'm going to subtract 4 from both sides. So I get negative 4 equals 4a. Divide both sides by 4. So a equals negative 1. Now I'm able to actually write the equation. So y equals, I'm going to write that negative 1 in there. X minus, nope, plus 2, because I'm using the vertex, plus 4. That would be my equation. Okay? Now, here's a question from STAR that uses this exact same skill. You'd have to use the vertex and use a point to plug it in. However, honestly, I would not go through all that work. What I would do is I would graph all 4 of these in my calculator until I found the one that matches this graph. Now, you don't have to do it that way. That's personally what I would do. I'm not sure which one is the answer. I think it might be A or C. But again, I'm not even going to waste your time going through this example because I would just put it in my calculator. I would graph each one of these and see which one looks like the graph that I've been given.